This is the last installment on operator overloading. The last video got a little bit long, so I decided to make one last video for one more topic. And in this video, I decided to create a new class from the date class. The date class got a little bit long, so this one hopefully will be a little bit easier to follow. Define a class tup, which is supposed to be like a class tuple. You can have two variables, x and y, and we have two attributes, x and y. We're just going to think of those as being numbers. String method, which prints those out as a tuple, so parentheses x comma y, and right parentheses. Now the interesting bit here is that for tuples I've defined an equals and a less than. And this is where the extra bit of information is going to come in, the source of this video. You can see it in equals here. When you call equals, say for example down here I have z1 equals z2, then Python will look for equals in z1 to see how equals is defined and try to determine the value of z1 is z2 or equal to z2 from here. Now it looks at z1 and calls z1's method for equal, which means that self is automatically, of course, of type tup. So self is going to be of type tup, but we don't know what other is. I could and have tried to compare something of type tup. So I have z1, z2, and z3. Are just three different tuples. And I've tried to compare z1 with an integer. So although self must be of type 2, other can be any other type, or can be also type tup. So I looked at then three different cases. The first case is that we're comparing a tuple with an integer. And you can have as many different types of classes in here as you want. You could have no classes at all if you wanted to. But I'm doing two different cases. In the case where I'm comparing a tuple with an integer, I ask that both attributes be equal to that integer. In a case where I'm comparing a tuple with a tuple, I ask that they have the same x's and the same y's. And then here's the bit that's different. If in any other case, if other is not an integer or not a tup, then I tell Python that that version of equality is not implemented and Python can deal with it on its own. Now I've done something similar here with less than. Checking to see if our tuple is less than an integer, I ask that self.x be less than other and self.y, oh, this should be less than other. I just made this definition up. This doesn't really mean much, but just have a definition for comparing a tuple to an integer, because you can do that if you want. If I'm comparing two tuples, this is not what I wanted. Hang on a second. What I meant to say is other.x plus other.y here. So I'll look at the sum of their attributes x and y and compare those. Again, that doesn't really have any mathematical meaning. It's just a definition to return a less than. And then if I'm not comparing with an integer or tup, a return not implemented. So let's look at the code down here. And again, I've got three tuples, z1, z2, and z3. And I'm asking, is z1 equal to z2? And that should be false. So when I do z1 equals z2, these are both tuples. And when I ask for equals, that's going to do this case right here and compare those. And for this one, we should get no. The x's aren't equal, so this should return false. Then we ask for z1 to be equal to 1. So we'll compare a tuple with an integer, and it's going to ask that x and y both be 1. In this case, it's not. But when we compare z3 to 1, both of those coordinates are 1, so that should be true. And then we're going to ask, is z3 equal to a? Now, in this case, we should get from equals not implemented. Why? Because other is going to be a string A, which is not an integer or a tuple, so it should go to this case. Now, we have something similar down here. Oh, I don't need this. We already have that up there. Well, I guess we can leave that there. We have a comparison with Z3 and 1, and we also have a comparison with Z3 and string A. So Z3 with 1, less than, we ask for self.x to be less than other, it's not. So self.x, oh, for Z3 is 1, and 1 is not less than 1. So this should return false. And in this case, comparing Z3, which is a tuple, to a string, should give us some kind of non-implemented. Alright, so let's see what happens when we run this. There's some subtleties here. Alright, so Z1 equals Z2. That's the false. Z1 equals 1. False. Z3 equals 1. True. In this case, we compare Z3 to a string A, and if they're equal, we print out Z3 as a string, otherwise Z3 not a string, and we get Z3 is not a string. Now, how did that happen? Well, so if we go up here to the equals, when Python looks at this, it says, okay, Z3 is of type tuple, so let's go look at the equals method. It checks to see if other is an int, it's not. It checks to see if other is tuple, it's not, it's a string. So it comes down here and returns not implemented. But Python doesn't stop there. It says, okay, so this is not implemented for Z3, but let me go and check to see if equals is defined for this. So A is a string, and so it goes to the string class and checks its equals method and says, hey, are these two things equal? And it turns out the string method is pretty clever on this and said, nah, Z3, this is not a string. These two things are not equal, and so it returns not a string, returns false. So this is a difference here with the equals and the less than, as we're going to see in a second. Alright, so now Z3 equals A, that's false. Z3 less than 1, as I said above, that is false because Z3 is 1, 1. And when you compare that with an int, it compares the first coordinate 1 with the 1. And 1 is not less than 1, so that returns false. And then there's one more. It asks for Z3 less than A. And we don't actually get an output for that here. But, well, we do, because we get Z3 less than A. Actually, we get it as a type error. And we're getting unorderable types. And the reason for that is, in this case, like with equals, in the case that other is a string, we don't have we return not implemented. But in this case, we go to the string class and look to see if there's an implementation for comparing a string with a tuple, and there isn't one. And the string class isn't smart enough to know how to compare those. With equals, it's smart enough to know that, well, Z3 is not a string, so they're not equal. But with less than, it doesn't know how to compare them, so it also returns not implemented, and then you get this error. Alright, so here's the general idea. You are free to define equals any way you want, especially for comparing two of the same types of objects. You are welcome to take your object and compare it to any other type of object if you want to, but there are inevitably going to be some things that you can't compare to, and in that case you should definitely return not implemented so that Python can use that error and report back if it needs to, or it also uses not implemented in this case to call a different method to see if that other method can handle it. And in this particular case, the string method was able to handle the equals. So leave the power to Python to let it deal with the situation by correctly implementing not implemented.